Can you all hear me clearly today?
Good
Yes,
afternoon, sir.
good afternoon.
Good afternoon. Can you all hear me today clearly without any glitches?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So let's hope that today's class is smooth and we don't have any network issues like we had yesterday. All right. Okay, so I think around 26 people have joined, 25 people have joined, so we can actually start looking at the stuff that we had started yesterday. So what were we doing yesterday? Let's have a look at the screen. So can you all see the board as well? The board where I am writing. Can you?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
perfect then. Let's start. Okay, let's start then. Fine. So yesterday we had started with these two words, stdin and stdout, and I have discussed and I have told you what they are. They are nothing but streams, right? They are streams, and these are like channels, right? From your input device into your, so here is your input device, and here's your main program, and here's your output device. So in order to read data from the keyboard, there is a channel, and that channel is called as an input channel, and it is known in C as your stdin. That's the name of your channel or the name of your stream. Okay. Similarly, stdout is the name of the channel or the name of the stream that connects your main program to the output device. So how does the data flow? The data flows in this direction. So from the keyboard, you take the data and you pass it on to your program, and from the program, if you want to display something onto your monitor, then that's the direction in which your data flows. Okay, I also told you yesterday, but since it was not clear, I'm repeating it once again, that if you have used Printf, right, if you have used Printf, then Printf is a function, which takes the output and sends that output to the default file stream, which is this one. Now, both the std out and std in, they are implemented in C using files. So that's why we call it as a file stream also. And we're going to cover this file stream once again later when we are actually working with files. All right. But this is a generic, it's a generic concept. It's a general concept that even when you do C++, this concept of streams will come into the picture. So let's not worry about that too much. Let's move ahead with what we had left in the last class. Okay, so in the last class, I already have a small program which I was writing yesterday, and let's continue with that. Okay, so let's continue with that. So I'm still going to write stdin and stdout here just for reference, and let's continue. So in this program, basically, what we were doing is I was introducing you to some other functions which use these two streams. Okay, so we know that printf is one function that uses these streams. Although we don't specify it automatically, it actually connects to the stdout stream. Okay, so today we're going to look at some more functions, okay, some more functions which are related to standard input and output. And I'm just going to list down those functions here. So the first one is getC, the second one is putC, the third one is getChar, and the fourth one is putChar. Let's look at these functions one by one. Okay, so I was writing a program yesterday. Let's try and finish that program. Now in this program, I have declared an integer variable. So this is basically the type of container which is going to store some value. Now, where is that value going to come from? So that value is going to come from the keyboard. Okay, so inside this ch, which is a container, I am going to take something. I am going to get some data. So I want to get a character. So this getC basically is a function which accepts a character. But an important thing is that this function does not know these streams, that which streams it has to connect to. So you have to tell these functions, this function specifically, the getC function, you have to tell this function that look, the stream from where you will get the data is stdin because that's connected to your keyboard, right? So inside this we write stdin. Many students, many people who actually write programs in C, they write this line and use it in their programs. But if you ask them what is this stdin, they will not be able to tell you. But now, since I've told you, you must remember what is this stdin. Stdin is the name of the stream through which the data is going to be accepted. Now, what does this program do? So I can print this out. So I basically take any character from the keyboard through the stdin stream using the function getC, and that character is converted into an integer. So getC, this function takes that character and the corresponding integer value it puts into this variable which is declared as ch. That's the reason we have declared here as integer, because the value that getC is going to return or it's going to give is in the form of an integer. So what we get in ch is a number or an integer. Now the question is, what will happen if I print? So if I print the value, right?
Sir, your voice not clearly audible.
My voice is again not clearly audible.
Sir, your voice not clearly audible.
Is it for everyone?
Yes.
No, sir.
No, sir.
No.
Audible, sir. No, sir.
Clear.
No, sir.
Audible.
All clear.
Okay, so I think if it's clear to everyone and it's not clear to you, that means the problem is at your side today, not mine. Okay, so let's continue. So what I was saying that yes, if you try to print this value now, let's say I write a program, I write printf, and in printf now I use %c, and all of you should be familiar with why I'm using %c, right? And if I do n, right, that means I want to print it to another line, and then what is the variable that I want to print? So the variable that I want to print is your ch here, which comes here, right? And then I just say return 0 and finish off this program. Okay, and this program gets over. Now, what will be the output of this program? The output of the program will be the character that you entered from your keyboard. So if you entered the character H, what will get printed out is H. Everybody understood that? However, if in place of C, in place of %C, if I change it to %D, then what's going to happen? We are not going to get H printed, but %D stands for format specifiers for integers. So it is going to print the integer value for this CH. What is the integer values for H? You can find it out. I don't remember. You can find it out from the program. Okay, so the ASCII code for H will be that integer value, which will be printed out. But if you want to print the character which you have entered, then you have to change this %D into %C. Is that clear? Everybody understood what is the function of this getC? Please respond and tell me yes, no, whatever it is. Okay, fine. So %C is a very simple function. What it does is it just connects to your stdin stream, right? And you have to specify this name here. And then what it does is it accepts a character, right? It accepts a character, and then that character is taken. It returns an integer value here, the integer number for the character that you have entered from the keyboard, and it, puts it into a variable, right? And after that, you can do whatever you want with the variable and print it out and use it for your work. Okay, so that's getC. Now, the second function here, which is C and getChar, are absolutely the same. What is the difference between the two? So the difference between the two is getC, we have to specify the name of the stream in getC. Okay, because getC doesn't know, this function does not know which stream to connect. So we have to specify the stream, the name of the stream which it needs to connect, or the name of the channel which it needs to connect to get the data. But getChar is a similar function, but in this case, you don't have to specify stdin. It knows it. That means the compiler has already bound getChar to stdin. Did you understand this? That means in the same program, I can change this program and the output will be same by just moving this getC and writing getChar. Done. That's it. I don't need to specify stdin. And getChar are absolutely the same. In one, that's how the function is designed. That's how the function is written. That in getC, you need to specify the name of the stream. In getChar, you don't need to specify the stream. Okay? Yeah, somebody's microphone is on. Okay, fine. So this is clear, right? Everybody got the difference between getC and getChar?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. The important thing is that in placements, all of you are going to strive for placements. I mean, even if after BCA or BSC, or if you're going to do MCA or MSc, at one point of time you're going to hit the placements and you're going to look for getting a job in the IT companies or wherever. Now, these kind of questions, right, which I am discussing right now, are going to be very important at that point of time. So whatever I'm saying, these small differences between getCh, getC, getChar, please make a note of it, because these are important from that perspective also. And anyway, it is also important to know, right now. Okay, so that's the story behind getCh and getC. Now we will look into another function, and the other function that we will look into it is putC, right? Now you must be, thinking that obviously this putC is a function which will probably print the values that we need to onto the monitor, and absolutely that's you're right. Okay, so putC is a function which writes a character. Writes, it doesn't read. Okay, reading means you're taking from an input device, that is a keyboard, but here we are talking about writing. So when you write, which is the file stream that we need to use? Anyone, come on. When we write, what is the file stream that we need to use?
Printf.
Is it file stream? I'm talking about the file stream. There are two types of file stream, right? stdin and stdout. These are
OUT.
std out.
this one, right? Because for reading, for input, we use this. For output, we use stdout. Now printf uses which one? stdin or stdout? Come on, let's see.
STDOUT.
STDIOUT.
Absolutely. Okay, brilliant. So you're getting it. So printf also uses stdout, because printf also prints your whatever characters and whatever you specify onto the monitor. Okay, so stdout is the channel or the stream which connects your program to the monitor. So when we talk about putC is another function which will also do the same. Okay, it also takes the input that you supply to it, and it will take that input all the way and release it into the stdout channel or stream, and that stream will take it and display it onto the monitor. So let me just write a simple example of this program. So I take a simple example. Now, in the first, I think for two classes before this class, I had discussed, A and small a. So what was the ASCII value of A? Do you remember? Anyone remembers? Capital A, what's the ASCII value of A?
65.
Absolutely, very good. Very good. Your memory is better than mine. Lovely. So the ASCII value for A, the capital A, was 65. So let's try to do that. Okay, we'll try to use that. So let's say I have CH, which is 65. Everybody's understood this line which I have written? It's very simple. I have declared a
Yes, sir.
variable. The name of the variable is CH. Okay, very good. So all those who have not understood, I'm just telling you once again, I'll repeat the initial steps many number of times because new people are joining in almost every day. So I have declared a variable, and that variable is of type integer. The name of the variable is ch, and this ch is basically a variable where I have stored an integer value. What is the integer value here? 65. And I know that 65 is the integer value or the integer code for capital A. All right. Now, normally we have been printing out. Using printf, right? We have been printing out the value. Like say, I can write this value, or let's say, let's skip printf altogether because I'm not going to use printf to display 65 onto the monitor. But I am going to use another function, and that function is putc. So let me just simply write putc here. So putc is another function, right? Now what putc does is it accepts two arguments. First of all, putc also you have to specify, just like getc. Now getc and putc are two functions in pairs. Okay, one is for reading and one is for writing. They are functions which are in pair. Like getc will read the values and putc will write onto the monitor. So since you remember that while using getc, we had to specify the stream, right? We had to specify the stream. So in while we are writing putc also, you have to specify the stream. But in putc, I need to specify the output stream. So I write stdout. Now, anyone who has attended today's class will know and will be able to explain why do we write stdout here and why do we write stdin in getc. Okay, because those are nothing but file streams. What are streams? All of you know. So these are small information which is very, very important, and these information will make you a better programmer. This will give you an edge over others. Okay, so understanding these simple, small stuff is very important. Now the next problem is that, okay, let me write return first, so it ends my program. The next problem that I have is putc is a function which is going to connect to the stdout stream. So that's fine. But what value does it give to the stdout stream? That value also we need to specify. So I have stored the value 65 into my variable ch. So along with this stdout information, I also need to give the value that has to be put into the monitor. So I need to specify the variable name here. Okay, so I need to specify the variable name here. Right now, what will happen is this ch, which is 65, using putc, will be sent to stdout stream, and on your monitor, what you will get printed is A. Okay, what you will get printed is A. Did you understand this?
Yes, sir.
Did you understand this?
Yes, sir.
Okay. Now you must remember one thing. You must remember one thing, that putc is a function. Putc is a function which is designed to take an integer in place of this. It is designed to take only an integer here. So you cannot supply a floating point value, a double or something like that. Okay, you can only put a integer here. So ch, I am supplying it as an integer, and it is displaying that ch as a character. Okay, so that's what it does. There is another function for writing, and you all know it is called as putchar. So these are functions which are related to characters. Okay, these are functions which is related to character. So that's why if you ask me, sir, why can't we use it for float and other stuff, then the answer is that these functions are specially designed to handle characters. Okay, now Now another function in place of put C can be put char, right? Now get C and put C are functions in pairs. Similarly, okay, get char and put char are functions in pairs. The usage of get C put C will be similar. The usage of get char and put char will also be similar. Now, just like how when we use get char, we did not specify the input stream because get char already has it inbuilt. That means it is a default stream is stdin. Similarly, for put char function, using put char, which stream it is, because this is the default stream for this is your stdout. Just like your printf, it uses by default stdout. Similarly, for putchar, the default stream is also stdout, and you don't need to specify it. So what you need to specify here is that data or that character which you want to print onto the monitor. And remember one thing, that data has to be specified in the integer as an integer number. So in this case, my ch is an integer. So what is the ch going to do? The ch is basically holding the value 65. So the 65 will get replaced here, and putchar 65 will take that 65, convert it into a character, and put it into this stdout stream. So once it enters the stream, it will directly flow to the monitor, and what will get printed onto the screen is A. Okay, so putchar uses stdout, put C uses stdout, get C uses stdin, get char uses stdin. What is stdin and stdout? Those are the file streams. Okay, what are streams? They are like channels which are connected from your program to either the input device or to the output device, depending on which stream we are talking about, input or output. So are you clear about this entire thing that I told you just now? Everyone, did you understand?
Sir, just a question.
Yes, sir. Yes, sir.
All right, great.
Sir, just a
Yes,
question.
okay, good. Yeah, somebody's asking a question.
Sir,
Okay, please.
sir, so there is only one difference between putchar and putc, that there is in putc we have to mention that standard out. So from which stream it's gonna take data?
Absolutely. Yes, putc is a function where it's the default stream is not specified, so you have to tell the stream name to that function. But putchar, it's default written for that particular. So when you're writing the code which has been written already inside the compiler, that code has got that they have inbuilt that stream into that function, so you don't have to specify it.
So putchar also specially designed for integers number.
Putchar is also designed for characters, to handle characters, but when you are inserting it, it accepts an integer value for that character.
Okay, sir.
Okay.
Okay, sir. Thank you.
All right. Okay. So let me quickly just take your attendance because everybody is. A moment before I just take you in attendance. Okay. So you don't have to do anything. You just relax. I'm just taking your attendance. So 1, 2, and 3. So your attendance is done. Okay, good. All right then. So let's move on. Let's move on with what we are doing. So you know the difference between. Let me write one small example and show it to you. So in this case, one more thing. Let's write this one example. So let's say I write a program like this. Okay. So I'm writing 65 here. I'm just writing one line. Okay. I'm writing 2 lines, and I write putchar 10 here, and say let's write one more thing. Putchar. Let's say 66. So just by writing these 3 lines, I can print 3 characters onto the screen. Okay, because I have used a function and have done, because I know that 65, 10, and 66 are all three integers, right? All of us know that. All right, or everybody knows, right? 65, 10, and 66 are integers. So if you write this for 65, right, which is A, will get printed onto the screen. Similarly, the corresponding character for 10 will get printed, and for 66 will get printed. So you can try in your program, put some random number and check what is the corresponding code for it. Okay, what is the corresponding character for it? Okay, so put char can be used to identify. Very simply, you can just write the function itself, give the integers, and then you can see what character is getting displayed onto your monitor. Okay, so you can try this program using putchar and putc and getchar and getc, and then things will become clear. Now I want to revisit the printf function once again. Okay, I want to revisit the printf function. Let's go and look at printf once again. Okay, now what was let me write the syntax for printf. So printf was something like this: printf, right? And you write some whatever text that you want. For example, let's say a floating point. Let's say a floating point. Then what you do, you put a colon, and then we write something which is called as access specifier, right? And then you write an integer, or you write something here. You can write say an integer. Okay, so we wrote a floating point, and here I'm writing an integer, and then after that I am just again putting for an integer. This format specifier is for float. All right, so then what do I do? Let me just full stop, and I'm going to close this. So that's closed. Now I have given two format specifiers in this particular line. The first format specifier is for a float, and the second format specifier is for an integer. Right. So what do I do now? So we have a floating point, and the other one has to be an integer. So let me write 123.45. Right, that would be for which access specifier, and then I separate it with a comma, and then I write 1 2 3 4 5. This access specifier is for which, sorry, this number, this value is for which access specifier? This one. Okay, so everybody basically is aware of this line that I have written, and you are clear about what are the different things that I have written here. Everybody is clear about this line? Please let me know.
Sir, can you explain again, sir?
Everybody understood this line? Okay, explain again. So when I write printf, so I'm revisiting printf. Okay, so when I write printf, so I can write any text which I want to print onto the screen. So value is, say, a text, any text, it can be anything. Okay, so this is what will get printed onto the screen. So what will get printed onto the screen is something like this: value, VALUE with a colon. This will get printed onto the screen. After that, I have written %f. What is %f? This is a format specifier. We have done it in the previous class. Okay, so %f will not get printed onto the screen. So I'm removing this. After that, I have put a colon here. That means my one part is done. I'm writing another part. So what is that another part? I'm writing, so here suppose I've written value 1, this would be value 1. So now I'm writing value 2. Okay, so same thing, I'm writing value 2, and here also let me specify, just like how I've written value 1 here, I'm going to write value 2 here with a colon. So what will get printed? Value 2. Okay, and this colon will get printed here. Yes. Now after this, I've written something which is not going to get printed. But what is this? This is the format specifier. Now, what is this format specifier? That means in place of this, some number has to be given which will be printed according to the format that you've given. Again, this is a placeholder. It is a placeholder. Where is this place located? This place is located here. Where is this place located? This place is located here. Okay, so in place of this, I need to give two numbers, and those numbers are going to get printed here according to the format in which you have specified. All right, so this is basically a placeholder. Okay, and what I have specified inside is the format in which this value needs to be printed. So obviously, let me close this now. Now the important point is supplying the two values. Okay, so the important point is supplying two values, one value for this and the other value for this. So since I have given this percentage F as the format specifier, this percentage F is the format specifier for a floating point number to display a number, a real number. That means a number which has decimal places. So I need to specify a number which has decimal places. So this number will go and fit in the place where the placeholder has been defined. So 12.45 will get printed here. Similarly, I need another number here. What is that number? Percentage D is a number for integers. So I need to specify an integer number here. And then this function closes. So this 123 is an integer for which the placeholder is here. That means this is the place where this number has to be printed. And what is the format? Percentage D. So what will get printed is 123. So this is going to be your output for this printf statement. So my question is, did you all understand what I have done in this printf?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right. So now, since you've understood, I am going to tell you something important. Okay. Now, since you've understood the statement which I have mentioned on the top, let me just delete a bit so that it's more clear. So here is percentage F. All right. And then you have to put a colon, a semicolon there, and then let me remove this mark here and write percentage D. Okay. Now this part, okay, this part right from here all the way till here, okay, is called as format string. This is called as your format string. Okay, format string. All right. So this basically defines what is the format in which your display has to be done. Okay, this will tell you all the formatting that you do, whatever statements that you write, whatever labels that you write, everything will come in this section, and this is called as format string. And the second string, the second part of this printf, which is this part, is called as expressions. Okay, this is called as expressions. Okay, what are expressions? Expressions are the actual values which need to be replaced in the placeholders for which they have been defined. Okay, so if I have percentage D, percentage D, percentage D in my format string, how many values should I have in my expressions?
3, sir.
3, sir.
Very good.
Three
Very
values.
good. And absolutely correct. And which type of these three values should be there?
Sir,
Integer type.
Integer.
Integer type.
Very good. Very good. So I have 537. So this is correct. But if I have something like this, that means my middle value should be a real number. Okay.
Yes, sir.
So the
Yes, sir.
sequence in which you specify the format specifiers, the same sequence needs to be specified in the expressions also. And these are very important because if you don't follow these sequencing, there will be issues and you will get errors in your code, and then you will not know where the problem is, because these are very, very fundamental issues. Okay, so you must know these small simple things. They are very simple, but they are important. Okay, everybody is fine with this? Everybody has understood
Yes, sir.
today's class till whatever
Yes, sir.
I have?
Yes,
Okay,
sir.
brilliant. Very good, very good. So, since everybody knows format specifiers and everybody now has understood that this part of your printf is called as a format string, let's try to show you all the some flexibilities associated with it. So let me just clear this canvas and get you to a new screen. Now, normally I write percentage %f, okay, to print any floating point number. Right. Now, if your number is 3.14, it will take 3 spaces here, right? It will get printed in this much of space. Now, what I can do is I can specify the minimum field width. Minimum field width. That means, like, suppose you have a box. You can specify the size of that box, a minimum size of this box. And if your value is also small, it will fill up this entire box and print. Okay, that means you are reserving this much space for your output. That means you are specifying a minimum width for your values. Now, all these kind of things that we are going to do is associated with formatting. Okay, is formatting, which means that if I write %f, it is a normal format specifiers, which is just asking you to print the values. So what will be the width of this 1, 2, 3, 4 character width? Okay, but if I change this and write something like %10f, mark very closely and mark very carefully. What I have done is I have written this character 10. I've written this number in between this. What it means is, right, there is a minimum width of 10 characters that is reserved for printing the value of floating point number. Okay, now when will this be important? When will this be important? This will be important. Suppose you are printing the numbers in a column. Okay, suppose you are printing the numbers in a column. So what will happen is, if you specify that the width of all the numbers is a constant width, then when you print those numbers in a sequence, then the output will be very nicely formatted. Okay, so let me take a small example. Let me take a small example and show you, because otherwise it will be difficult to understand, because since we are having online classes, it's a challenge. So let's say I have a number, and the first number is 12, and say I have another number, and that number is, say, 1, 2, 3, 4, 5. All right. Now I use a very simple. The first one is, let me use a very simple printf. So I use a very simple printf, and what is the format? So I'm writing %d, and I'm writing this /n so that the next number will get printed below this. All right. And I have to, because I have used in format specifier here, so I need to give a number here. So what is the number I'm specifying? I'm giving number 1. Now this is no rocket science. So what will get printed on your screen is 12. That's it. Okay, everybody should have understood this. Now let's go with the second printf statement in the same program. So I'm writing a second printf, excuse me, and in this second printf, let me try and print the second number which I have, number 2. How will this number 2 get printed? It will get printed like 1, 2, 3, 4, and 5. I think this is also easy to understand, no rocket science. Let's bring the third one now. Now, when I write the third printf statement, what I'm going to do is I'm going to add a minimum field width. Okay, so I am going to change here. Now look very carefully. I'm writing percentage, and I'm writing 5, all right, and I'm writing D. Okay, I'm writing 5 and I'm writing D, and then I'm writing this. Okay, and let me print the first number. So number 1. Now, where do you think this 12 will get printed. Now what is going to happen is, for this number 1, what is the minimum field that this particular percentage 5D is going to reserve? 5. Okay,
5.
so 5. So which is 5? So this much is 5, right? This much of width is 5, because 1, 2, 3, 4, 5. So where 12 will get printed? The 12 value will get printed here. And space 1, space 2, space 3. These 3 spaces will be left blank. But my 12 will get printed here. Did you all understand this? Did you all understand this?
Yes, sir.
Yes, sir.
Yes, sir.
So now the good thing about this is, if you want to print the values in a sequence, and if you like have something scenarios like this, and if you have numbers which are of, some are in 10, some are in 100, some are in thousands. So when you take a percentage 5, a percentage 10, or percentage 12, or whatever, for all the different values, your number will get very nicely printed: 135, 6321, 8321, 26, 653. So this is the way in which your numbers will get printed in a very nice way. So if you look at this, what is actually happening is, the space is being provided. That means if this is 5 space here, this 5 space is being reserved, and the numbers are being right aligned. Isn't it? It's being right aligned. That means it is not starting from here and leaving these 3 spaces here, but the 3 spaces are being left in front. Are you getting it? The 3 spaces are being left in front, and then that number is being written. So we are basically doing right aligning here. All okay?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now you can do
Yes,
one
sir.
more thing. You can do one more thing here. What you can do one more thing. Let me write one more scenario so it will become clear. So let me write another scenario where I'm writing percentage 5 D slash N. Okay, and here's a comma, and I'm writing number 1. So what should get printed? 1 and 2 should get printed, right? This. Now, in place of this, I've left a space here. That means I can also specify any character that I want to fill in these spaces. I can also specify the character that I want to fill in these spaces. Okay, so if I give a character something like this, suppose whatever I write here, this character, those character will be filled in these blank spaces. Okay, so if I write 0 here, that means 0.05. What will happen is 3 zeros will be printed this way. Did you all understand?
Yes, sir.
Okay.
Yes, sir.
Did you all understand? Okay, very good. Now
So
I'm going to ask.
if we write 1 5, then 1 would be printed instead of 0.
You try it in your program, try it in your lab, and tell me in the next class. Try to do 3 scenarios. Try to put a star, try to put a number 1, and try to put a character, and tell me in the next class what is going to happen. So that's an assignment for you, all of you. Next class I'm going to ask you, and I want to ask randomly, and I want to see whether you have tried this in your lab or not. And if you're not able to understand what this is happening, then I will explain it to you. But please try this as an assignment, and on Monday or Tuesday you have to tell me what is the result. Okay,
Okay, sir.
Okay, sir.
fine. Okay, fine. Now what's the time? Okay, we still have 10 minutes left, so I can tell you something extra also. Okay.
Sir, say there is a, you have mentioned in last line that percentage 05 comma D or 05D.
Sorry, D. It's 05D.
Okay, okay. No.
Okay, it's percentage 5. All right.
Sir, yes, sir.
Okay. Fine. Okay, let me think if there is anything. Yes, one question for you. Okay, now let's look at this. Okay, if I write something like this, percentage 2d slash n, and I'm writing number 2, please tell me what is going to happen. What do you think
So,
will happen?
so it would print
So it's going
from
to print 1, 2.
2 digit. Like
So number 2 is basically which one?
Only
1,
for
2,
print
3,
4 digits.
4, 5. It will print only 2 digits.
oh no, it would start from the second digit. Like in front of it 2 spaces, and then it would start 1, 2, 3, 4,
Okay.
5.
No, what is going to happen is it's going to print 1, 2, 3, 4, 5. Why? I'll tell you. Because this space which I have given is 2 digits, right? I've given a space for 2 characters, 2 digits. But this character itself is a 5-digit character. Okay, so what is going to happen is this 2 is going to get replaced by the minimum length of the character. So what is the minimum length of the character? 5. Did you understand? So if you write any number here which is less than the size of the actual value, or the less than the format size of the actual value, then this will be overwritten and your actual value itself will get printed.
By default, it changes.
Yes, by default it changes. Okay, did you understand?
Yes,
Yes,
sir.
sir.
Okay, brilliant. Now, since we have 10 minutes more, I can probably. Are you all able to understand, right? Or it's getting too much for a day? If you're getting overloaded and you want me to stop, you can just tell me. But I'm telling, since we have time, I'm just trying to add some more extra bits into it. So let me try and tell you one more small thing here. Okay, so if you notice that by default these values are getting right aligned, isn't it? By default these values are getting right aligned. So what can I do to make it left aligned? Okay, so if I have a requirement that I want to print everything in left aligned, all right, that means what is the meaning of left aligned? So suppose if my values are printing like this, suppose I have 5 numbers: 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Now I think all of you can at least print this on the screen, right? Nobody will have a problem. Everyone can print this onto the screen. So in the first printf, you will give 1, you will give percentage 5d, right? So 1 will get printed here. In the second printf, you'll write percentage 5d, and here you will write 1
Yes,
and
sir.
2, right? All of you know, right, what you have to
Yes,
do.
sir. Yes, sir.
So by giving percentage 5d, you will get an output like this, because 5 spaces, 5 spaces, 5, 5, 5. Okay, but all these values are right aligned. Now suppose I want them to be left aligned. Okay, if I want them to be left aligned, but still I want, suppose my format, I wanted something like that, like I write here 1, that is left aligned, and then 1 and 2, so this is left aligned, 1, 2, 3, left aligned, 1, 2, 3, 4, left aligned, 1, 2, 3, 4, 5. Suppose I want to print it in the, like a mirror image, not exactly a mirror image, but you know, the format is a mirror format, which is, this is right aligned and this is left aligned. So if I want to print something like this, then what do I do? Very simple, very simple. So concentrate. Percentage D is for what? Integers, right? Percentage D is for integers. Now along with that 5, when I mention, I'm saying the minimum field width, right? And negative sign. Okay, if I give a negative sign, that it means what? It means left aligned.
Left aligned.
That means you will get this way. If I don't put a negative sign, which is default positive, that means it will be right aligned. Did you understand?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Okay. Very good, very good. So I think we can, you know, keep it here, and otherwise it'll be too much. We can also do some kind of, for example, floating point. If you are dealing with floating point numbers, right? And if you want to format the floating point numbers, there are different ways of formatting it. Like, you can also specify the precision and all that stuff, so that we're not worry about it. But please remember what I have told you today, right? So if I give you if I give you a simple program to print values like this, I think you should be able to do it. So if I give you a program to print like this, will you be able to do it?
Yes, sir.
Right, very simple. Right, what you're going to do. So in the first print statement,
So it would be two loop, right?
no, there is no looping. We have not yet started looping. We are doing printf only. Loops I have not taught you yet. Nobody knows loops. Okay, nobody knows. Even if you know, you don't know, because we have not yet started loops. I'm talking about with whatever we have studied so far. You have to write. How many printfs are you going to write for this particular problem? Tell me. How many printf statements will you write for getting an output in this format?
Four.
Four printfs, right? Very good. So in this printf, you will be writing something like this. So percentage 5D, isn't it? And then this side you will be writing percentage minus
5D.
Correct?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
And so one printf will have this. The second printf will have the same thing. Percentage 5D, percentage minus 5D. And what are the values that you're going to supply for the first printf? The values that you're going to supply for the first printf will be 1 and 1.
1.
Right? So I think
Yes, sir.
everybody has understood. So for the second printf, you're going to write 5D and you're going to write minus 5D. Same thing, right? As above. But what is the value that you're going to supply? 12 and 12.
12.
Okay. So you guys can try this small example. And what is the value that you're going to supply here? 1, 2, 3 and 1, 2, 3. And the
Sir.
last one. Yes.
So what if I don't write minus 5D, only %D?
If you just write only, if you don't write minus 5D, then it will just print normally without, like for example, if I have two numbers 1, 2, 3, 4, 5, and if I have 1, 2, right, and if I just print them without giving any kind of access specifier, then how are they going to get printed? It will get printed like this. 12 will get printed here, and then you have 1, 2, 3, 4, 5, right? And if you again put percentage D, if you put percentage D, then 12 will get printed here. Percentage 5D, then 12 will get printed here. Okay. Then if you put percentage minus, then it will get 12 will get printed here. So with minus, it will become left aligned. But just by putting minus, it doesn't make sense. You have to give some width, and in that width, you are talking about right aligned or left aligned. That means if my size itself is this much and my number is packed, will left align and right align have any meaning? No meaning, right? Because right aligned also is this, left aligned is also this. But if you have the space is large and your number is only small, now when I talk about right aligned and left aligned, there is a meaning. That means if I say left aligned, then the numbers will be here. If I say right aligned, then all these numbers will shift and come here. So if there is a space inside your box and your number which you're writing is small, then we can talk about right aligned and left aligned. But if you have exact space, that means there is no space on the left side, right side, whatever is your 4 digits means exact 4 space. If you write left aligned or if you write right aligned, it doesn't make any sense. There is no meaning. So if you don't write a number before percentage D, right? If you don't write this, right? And if you just write something like this, putting minus does not make any sense. Did you understand?
Yes, sir.
Okay, fine. So I think
Yes, sir.
that should be fine. So we have how many people?
Can you show me the program, sir?
Which program?
The assignment which you gave. I mean, I need to note it down.
Okay, so the output basically is this one.
Okay, okay.
Sorry, 1 second. I've got it all over the place. Hang on. So this is the output. Try to write a program using 4 printf statements to get this output. Okay, can you all see it now?
Yes, sir.
This is the one.
Yes, sir.
Okay, so that's your assignment for today. Okay, fine. So we will see you. I will see you again next week. Till then, practice whatever I've been doing. I hope all of you have computers. Anyway, your systems are going to arrive soon. Already, they have been procured, and they are being dispatched. That's what I heard. But you can still be in touch with your mentors to find out when are you going to get it. But most probably you're going to get it very soon. Your books as well as your systems. So anyway, I know you're more interested in getting the systems, isn't it, rather than books?